So we talked a lot about 2 dimensions. So what about 3 dimensions? Right? How many vectors do you need to span 3 dimensions? All that means is that how many vectors do you need so that you can add them up in some linear combination to represent any vectors in 3 dimensions. So let's draw a 3 dimension here. And let's say we had 2 vectors that look like this and like this on the x, y axis. Okay, so these are on this plane here. It's hard to visualize sometimes, right? It's just purely on that plane. Doesn't go up. Okay, there's no vertical movement. Just stays on that plane. Now with those two, can you create, for example, a vector that will go up like this? Clearly, we cannot. Okay, we need some z component. So intuitively, because we added an extra dimension, we actually need 3 non-parallel, actually we should say 3 linearly independent. Okay, vectors will span the 3 dimension. So what this linearly independent means is this. Let's say you have vector A and vector B and vector C. If vector A, B, C are all linearly independent with each other, it just means this. So if A is linearly independent of B and C, we cannot do this. Okay. So this is impossible to satisfy with any m and n. Okay, there's no m and n which will make this true. Okay, so no m and n can be found so that, let's say, let's call this star. Star is true. Okay, so we've done some examples where we had the situation, right? Visually, the situation was we're on the same plane. We had like vector B and C, and here's our A. So we were able to create this one using some linear combination of these two. But now, this cannot be on the same plane. That's what it actually means. If this is impossible to be true, we're talking about this case where we have 2 vectors, but the third vector is going up like this. So there's no way we can create that vector using these 2 vectors. And there is no way we can create this vector with these 2 either, because those 2 only will define that plane right there. Anything in that plane, right? And also, lastly, this vector will also not be, you cannot make this one by these 2 vectors, which can only create vectors that are on this plane, right? This vertically going up. Okay. Saying that, another way of saying that is 3 vectors are not collinear, okay, not collinear, not parallel, and not coplanar. 3 vectors are all in the same plane. They have to be in different plane, okay, different plane.